Okay, I am here in my Colab notebook. I'm just going to walk through the code. So this is how we just connect to Google Drive to get the files. Then we're able to copy over, get these files in here. And then we're doing all our imports. So these are all the libraries we're going to use. And this is from this Python file. So we're just getting all the libraries. And then this is just outputting some of the basic data from this original iris.data. Just getting the basic information from unmodified data. And this is just displaying the class labels. So this column on the very right, just displaying those so that we can see them all. And then we'll use, I think we'll use that later. And then here we're just, giving each of them an integer because obviously this string doesn't mean anything to the computer, so you assign each one an integer because that's a lot better for processing. This is where we can filter data. It's commented out because it doesn't do anything because this is always true for every piece of data, so it's not filtering any out, but this is how we could clean up data if we needed to. Here we're randomizing it, which is really important because it's ordered by the class. So if we don't randomize it, our training and validation data our validation is always going to be the last 30 lines, which is all the same class, which is just not representative of the data. So we're going to want training validation data to be random so that we can actually represent all the data in each of them. And these are some functions that we're going to use to continue to pre-process the data. So this df selected is just a data frame, gets all the features that are already in it, and then we make a copy of that, and then to that copy, to this data frame, we're adding sepal area just as another feature. So we basically just create a data frame that represents all of these and sepal area in this one. And then this one is similar, but it gets the actual labels for the data frame only. So we're just going to get the targets or the labels, and then that's what that's going to do. This is partitioning our data into training and validation data. So we do 80% training, then the rest is validation. And then this is going to be for our, what's it called? Cross something, I forgot the name. But that'll be for validation, cross validation, of course. Okay, so this is where we're actually going to break we're going to get the number of examples of training and validation data. So we're breaking this one into 80%, and the rest will be the validation. Then we are getting all the features using that function that we discussed and storing them in data frame and getting all the targets. And then we are doing the same thing, getting all the features and targets for the training and then also for the validation. Then this is just a display just to see that we've actually done it correctly. So if we go ahead and run this, you can see that, you can see it's split into 80 and 20 like we talked about. We can see the training features. There's 120 of them. Then the mean, validation, 30 of them, and then these values will be pretty similar because the data it's a little off because it's not the exact same data, it's separate data. And then this is just showing that we have the labels. There's 120 for training, 30 for validation, which we expect. All right. So this is now standardizing it to a normal distribution. So we use the scalar, and then we're able to just fit the data frames for training and validation to normal distributions. And we're just displaying this on the screen. So you can see, like we expect, the mean is close to 0, standard deviation is close to 1. This one is a little off because we're using the scalar created for the training data on the validation data. So it's not actually 0 and 1 like you would think, because it's not the scalar created for this data, but that's okay. And then here's some variables that we're going to use to hold for a different, we're going to have multiple models, so we're going to have the names, the actual models themselves, their predictions that they make, and then the confusion matrices for them. So now we're actually going to train the data. So we'll see. First, we're going to do the logistic regression model, import the model, stored in this variable. You just call it, pass these parameters, fit it to our normalized data using this Ravel to make it a 1D array, a 2D array to a 1D array. Then adding that to the models list that we talked about up here. And then we're printing it down here just so we have a representation to see that we did it. Then we do the same thing for our support vector classification model. We just change this new parameters because it's a different model, and then we just fit it the same, append it the same, print it the same. And now we're going to actually make predictions based on that model. So we're going to loop through each model, because this is our list of model names. We're going to make a prediction using the model of the normalized validation data. And then we're going to add that prediction to our predictions array. Then we're going to print that specific prediction. Or no, we're going to print a line saying predictions. Then we'll print that specific prediction as well as the actual value, so we can get a little comparison. You see it does it for both models. It's pretty accurate, but there's a few differences like right there. But yeah, and then you can see this one will be slightly different prediction because it's using the other model. So like this 2 and this 1 are different. All right, now we're gonna print out the results nice, make our confusion matrices. So again, we're going through each model. We're just making a confusion matrix based on the validation targets and the predictions we make. And then we're adding that to our confusion matrices list. Now we're just going to display it. So for each model, we'll print the name and the prediction accuracy. So we'll say we'll have our percent split here, just so we can visualize what it is. So you can see that 80-20. Then we'll calculate the overall score of the model, just using the score function, using the normalized validation data and the targets, because that's what we're predicting on. And we'll print that out, multiply it by 100, so it's a nice percent right there. And then we'll print out the scores for the individual classes. So you can see that's what this is right here. We loop through each of the different labels, which are the classes. And then we'll print out, this is calculating the percent for each of them. And then we're also gonna do our cross validation like we talked about earlier. We will pass whichever model we're on, the data frame of all the features, data frame of all the targets, convert it to Ravel, and then the cross validation number that we defined as 5 earlier. So we'll print out that number, and we'll get the actual result here, print that out, so you can see that right here. And then we'll actually display our confusion matrices. So for each model, we're going to have the title, which is going to be just this string right here. Create a confusion matrix data frame. Pass the confusion matrices for this model. The index will be the CM labels, and the columns will also be the CM labels. So you can see that's what these are. And then we're going to use this pretty plot confusion matrix from this Python file. And then pass these parameters of confusion matrices. The prediction axis is going to be our x-axis. And this is just going to be the colors, and the title will just be this title we named earlier. And then, yeah, we do that for both models, and we get these nice confusion matrices for each one. And that's it.